Today we're going to see one more interesting problem from Blind 75 series, which is two sum. So basically what a question asks you to do is they will give you a list of integer and a target element. You have to pick a two number that makes up to the target. Okay. So if you take this example, you have to make 9. For that, you can just pick 2 and 7, add them together, which will give you to the 9, right? So you have to return the index position of it. If we see the index of it, see 0 1 2 3, if we see the index of this two number, it will be 0 comma 2. We have to return this is a simple solution, simple question. And let's think another scenario. So what is your target is going to be 10. How do you make a sum of 10 with this given integer? If you try to check every combination, you cannot actually make the sum 10 from this given element, right? You cannot make a value 10. So if you add 2 plus 11, it's going to be 13. If you add 2 plus 7, it's going to be 9. If you just add 2 plus 15, 17 again. If you add this both, it doesn't equal to 10. If you add this both, it's not going to be equal to 10. So in that case, you just need to return -1 comma 1. This is what you have to return for this case. For invalid case, for valid case, you have to return the index. I hope you understand the question. So now let's jump into the brute force solution. So if we think about the brute force one, it's very simple solution. Okay, so you just pick an element, you just compare with every other element and just check whether this sum actually makes up a target or not. It's very simple. I will just write a pseudocode. You can just understand way much better. Just start a loop from 0 up to the nth element, and the inner loop will go from I plus 1 to the n minus 1th element. Okay, and as I said, we just simply check if nums of I plus nums of j making up a target or not. If it's making up target, just simply return index of it, I comma j. We can just simply return this value. If everything is fails, I mean if this case didn't pass, then we can directly return, you just come out of the loop and you return -1 comma 1. This is simple brute force solution. Okay, it's very simple. And if you analyze the time complexity, the time will be big O of n square and space will be big O of 1, because we're not using any space. And for the time, this inner loop will take O of n time, and this one also will take O of n time. If you just multiply it together, you will get O of n square, because this inner loop, okay, so if you're using inner loop, you have to multiply it. If you are using two different outer loops, you have to just add it. So our time complexity will be O of n square for brute force one. So now let's move to the optimal solutions. So what does we are trying to achieve is, we are trying to reduce the time complexity for this problem, because if you see space is already constant. So now only one way to optimize this problem is the space. So you have to reduce big O of n square to the any other better solution like big O of n or n log n. This is the better time complexity than big O of 1. This is what you're trying to do it. If you take big O of n, like if you want to trim it down to big O of n, what is your thought process will be? So what does big O of n tells? The big O of n tells you have to visit every element at once. So then only you can get big O of n, right? So by this, what you can understand, just think. If you're just visiting one time and you need to find the target element, how do you achieve it? So for that, what we can do is, let's say you are at 7, okay? So what does sound indicate? What does sound indicate? So you need one more element to make the sum 9. So how do you find this one more element? How do you find? You can just do simple math. You can just take this 7 to that side, and you can minus, like 9 minus 7 will give you 2. So you have to know that 2's exist in this array or not. So how do you do that? How do you know that 2's exist here? Just think for a while. Just think what data structure will be used here. Okay. If you guessed it correctly, that's well and good. So if you want to remember something, so you have to use HashMap, right? So we are seeing HashMap in last two videos also. So if you just want to remember something, use HashMap. So you don't know whether 2 is there or right. So you just need to remember it. So what data structure will be good as HashMap. If you hashed like 2 is exists, then you can easily tell that 2 is exists. Now we found the target. Just add with 7, which will make up to the target. That's it. It's very simple. This is a thought process for the optimal code, hash, which use the HashMap. It's very simple thought process. Okay, now let's do a quick dry run. Okay, I will make an hash map now. Okay, now what will be our key? Our key will be the number. Okay, the number which we visiting here will be our key, and then our value is going to be the index of it, right? So our question tells us to return the two index. So we just keep key as a number and index as the value. Key sorry, this is going to be number comma index. This is going to be our value. Now let's do a quick dry run. Okay, now we'll iterate to the array only once. Now we'll see 2. We'll check, we'll just substitute the formula which we did previously, like 2 plus dash will give you 9, a simple math. So 2 plus which will give you the target is 7, right? Just check whether 7 is there in our hash or not. No, we didn't see 7 so far. So we just put this value inside the hash map. Now we'll just move on to the next one. Now 11 plus dash will give you the 9. So if you take 11, you need minus 3, right? Oh, sorry, 1. Yeah, you need minus 2. Does minus 2 exist there? No, minus 2 doesn't exist there. So just put the value in the hash map with index 1. Now you just move to the 7. When you come to the 7, the same equation going to come. 7 plus dash is going to be 9. So which element you need that will sum up to the 9? Just think. You need 2, right? Now you just check the hash map whether 2 exists there or not. Yes, our value 2 exists. Now we can directly tell that, we can directly return that the index of 2, we'll just take this value. The index of 2 is 0. We can directly return 0, comma, what is this index? Index of this value, 7. It's very simple, right? You can directly return 0, comma 2 if you use HashMap. This very simple, this solution is very simple. Now let's write the pseudocode for it. Now we'll just declare an HashMap. Hash is going to be, now we'll just iterate the every element once. I is equal to 0 up to the n. Now we'll calculate the needed, the formula which we wrote here. Okay, so how do you do it? You just what you just need to do, target minus the current element. That's what you will do, right? You'll just take this number to this side and minus it. Now you need 7. Same here, you just bring that to that side. Now this will become minus 2, and then again if you bring it here, if you do it, you will get 2. This is just simple mathematical formula. You are just doing it here. You need it. Now we're just thinking if needed in hash. If it's there, you can directly return it, which means you just found a 2 element that will make a sum up to the target. You can directly return the index position. So hash of needed, comma, the current element, current index. That's it. It's very simple solution. And if what is the else condition? else condition is going to be, what we did here is, if not found, we just added to the hash. That's it. That's the else condition. Now hash of num is going to be index. Simple solution, simple thought process. Now let's analyze the time complexity. So what we did best. If you analyze time complexity, as we talked, we are just iterating the loop only once. So the time is going to be big O of n. Now let's talk about space complexity. So now we are using an extra data structure, the hash data structure, which is going to take O of n space. Remember what I said in first video. If you want to optimize something, we have to give up on something. So we just give up space O of n, sorry, O of 1. We just give up on it. And now we just increased our time complexity. Increase in the sense from worse to the better one. Before it was O of n square. Now we just increase the space. Now the time complexity becomes O of n. That's a very good approach. And in future you will find a problem where decreasing space will decreasing time will increase the space. Like that problem we'll see. That will be very interesting. We'll see those kind of problem in the future. And we'll see one more approach how to solve this problem optimally. Let's say the interviewer asks you to do this problem without using hash. Without using HashMap, how could you solve this problem? Just think. Without using HashMap, you have to solve this problem. So without using HashMap, how we can solve this? Let's take the same example. So what's a thought process is, just sort the array. Okay, just sort it in the ascending order. Like if you sort this, this will become 2, 7, 11, 15, right? Now we are going to apply two pointer technique. So two pointer technique. So what does two pointer tells us, you will keep a two pointer, one is at the starting, one is at the ending range. Now let's keep the two pointers here. Now you just add both of them. If you add both of them, this will give you value 17. Just check whether it's greater or lesser than the target. Our target is going to be 9. So this is going to be greater than our target, right? So the given, I mean, we just sorted it. Now if you want to reduce the sum, so what do you do? What you have to do is, you have to move to the smaller side. So from where you can go to the smaller side? Just think in the sorting order, how do you go to the smaller order? You have to go from right to left, right? If you move from right to left, you can see the values are getting decreased. So you have to move left side. And how do you get the increasing sequence? You have to move from right to left. If you see right to left, the order is getting increased, right? That's the core logic for this solution, or a two pointer solution. So now the target is greater than. So if you want to minimize the target, we have to move from right to left, because right to left is decreasing sequence. So now let's move the pointer from here to here. Now let's do 2 plus 11, which gives 13. Again, it's greater than target. Again, you have to move from right to the left. Now you came 2 plus 7, which gives 9, right? This is equal to target. You see, now we reached the target with another approach. This approach is so good. But if you see the time complexity for sorting, it will take nlogn, right? But what if interviewer asks you to do without HashMap? This is the best optimal code without using an HashMap solution. If you use HashMap, it's going to be O of n. But if they ask you to do without HashMap, you can follow this approach. Again, you can ask me, how can I get the index? That's a good question. For that, what we can do is, we can create the new array with the with the number and their index. So this is going to be 0, 1, 2, 3, right? Now just write them in this order. 7 is going to be 1, and then 11 is going to be 2 and 15 is going to be 3. You can just club them together, and you can write a sorting algorithm which sort based on this element. You have to make a new array, right? You have to make a new array with this kind of structure, which need to be like number comma index. Now if we sort, according to the 0th element, you can just get the sorted order. That's very simple. You can just apply the same logic. Just take the number, add them together. If the sum is greater than target, you have to move to the left side. Again, if sum is less than the target, you have to move to the right side. Simple logic, simple approach. Now let's write the pseudocode for it. Now we have to make the new array, right? Now let's give the name for an array. Now just look through the index. For I is going to be 0, I is going to be 0 up to the nth element. Now just array dot push. The structure what we talked is number comma index, right? Number comma index. Now we have to sort it according to the 0th item. So the 0th item is num. According to that, if you sort it, the final array will look like this. If you sort with this 0th element. Now after that, what you have to do is we have to declare left and right pointer. Left will be at the 0th index, right? Left will be at 0th index, right will be at the last index. Now right is going to be n minus 1. N is nothing but the size of an array. Okay, so it will be at the last index. We'll keep them up. Now we'll write the condition while left is less than right. That's a base condition, right? It should be less than right when they both interchange, which means we see all the element, right? So that's why the base condition is left is less than right. When this condition fails, which means both the pointers in all the element. That's what this condition tells us. Now we just sum it. Sum is going to be array. Don't forget we created another data structure here. We have to use it. We have to use this one. For that, what you have to do is we have to use array of left, and you need to access the first element, because first element has the number and second element has the index value, right? Access the first element, and array of right of 0. Now if the sum is equal to target, you can directly return the answer. Return left comma right. So simple, right? This approach. Another case will be like elif if sum is greater than target. So what I told you guys, if sum is greater than target, you have to minimize it. For minimizing, you have to move from right to the left, right? You can just make right minus 1, right minus, and then what is going to be the else case? You have to increment, you have to move left to the right. For another case, left is going to be plus 1 1. That's it, very simple. At last you can directly return minus 1 comma 1. Minus 1 comma 1 tells you that no two pair found to make the sum of the target. This is the final condition. If we found the target, we will return here. If none of the pairs found, we just return -1. This is going to be outside of the loop. Again, if you analyze the time complexity, it's going to be, for sorting, it will take big O of n log n, right? Big O of n log n. And for this loop, this is going to be take again big O of n. And then it's going to be space is going to be, this is going to be a little controversial. What I tell is big O of 1 is constant space. The reason because we are not creating any extra data structure, right? We are just manipulating the given given array. So we're not creating any extra space. We are not using any extra space than it required. Yeah, somebody might argue it will be like big O of n. Yeah, that's also right. But what I think is the correct space is going to be O of n. O of 1. O of n is also good. But if we think carefully, we are not creating or we are not using any extra space. We are just using the given array in a different format. That's it. Now let's quickly code this app. We're going to code HashMap solution. We are not going to go with the second solution which we see. I mean the second optimal one. So now let's quickly code this app. we'll declare the hash, and then we'll iterate the array only once, right? For I in range, it's going to be go up to the size of an array, and we just put this formula. Needed is going to be target minus the current element. If needed in hash, we're just directly going to return directly going to return hash of needed and the current index of it, right? If not, we're just going to add the current element with the index to the hash map. Hash of I, not I, sorry, hash of nums of I is going to be equal to I. Now we can directly return -1, 1. This is going to be for invalid case. If none of the things found, we just return this. Now let's run this. Yeah, it passed all the test case. Now let's submit it. Yeah, it successfully got submitted. And that's it for this video, and we'll see one more interesting problem tomorrow. Until then, bye.